Okay, here's our video on multiplying in scientific notation. Now, to multiply in scientific notation, you need to know some exponent rules. And for this purpose, fix that for you. Okay. Now, in exponent rules, when you multiply exponents, the same base, if they have the same base, remember exponents, you have a base, let's say 3 squared, 3 is the base, the 2 is the exponent. So when they have the same bases, you just add the exponents. Like if they had 3 to the second power times 4 to the second power, they don't have the same base. You need to have the same base. So with the same base, well, they don't need to have the same base, but for this purposes of doing scientific notation, when you have the same base, just add the exponents. So if they had 3 to the second power times 3 to the third power, well, now they have the same base. So you would keep the base and add the exponents. So that'll be 3 to the fifth power. Now we will go over exponent rules in another video, but for this purpose, for these purposes in this video, with scientific notation, you already have the same base, which is 10, so you just add the exponents. So let's do another example here. Let's say we had 2.3 times 10 to the third power, and we want to multiply it, right? We want to multiply it by, let's say, 3 times 10 to the eighth power. Now they have the same base because it's 10. That's the base. So what you're going to do is you're going to multiply 2.3 times 3. And then you're going to keep the base and add the exponents. So multiply 2.3 times 3 and see what you can get in scientific notation. So your answer will have a base of 10 because you're going to keep the base. And then what do you do from there? Okay, so 2.3 times 3 is 6.9, right? So we have 6.9, and then we're going to add the exponents. That'll be our answer. Okay? Let's try this one now. Here we have 2 times 10 to the fourth power multiplied by 3 times 10 to the second power. So we don't have to put the multiplication sign because 2 parentheses mean multiplication. So again, with scientific notation, they both will have a 10. They both have the same base. So all we do is add the exponents. So we know it's going to be 10 to the sixth, and 2 times 3 is 6. Let's try another one. Here we have 2 times 10. Well, here we're going to prove it. So we have, this is proving it, because we know 2 times 10 to the fourth power is 20,000. And 3 times 10 to the second power is 300. So if you multiply them, you'll get 6 million. And what is 6 million? It's just 6 times 10 to the sixth power, which we had before. Keep the base is 10, and just add the exponents. 4 plus 2 is 6. Let's see if you can do this one. Be careful because there's a little trick involved. Try that one. You should pause the tape and try that. Okay, now the first problem is it's not in scientific notation. This one's in scientific notation, but this one's not. Now you can still do this because, again, like I said in the last video, this is still a perfectly good number. It's just not in scientific notation. So what you should do first is you should change this. Change it into scientific notation. So remember, in scientific notation, we have to have the decimal right after the first number. So before, let's look back, it was 10 to the sixth power, but we're moving back 1. So if we move 1, we have to, that means when, from here, we're going 6 times. 6 times that way. But if we go back 1, now we have to go 7 times, because we added 1. So that would be the answer there. So now, again, we keep the same base, like always. We add the exponents. 7 plus 6 is 13. And if you multiply these two together, you'll get this answer. So you should rewind the tape if you don't understand how we went from a 6 to a 7. Okay, now, let's see if you can do this one. Try that. Okay, hope you pause the tape. So they do have the same base, so we know it's going to be, whatever our answer is going to be 10. But we have to be careful. We need to know what this answer is before we put our exponent in. So when we multiply 9.23 times 5, we're going to get 46.15. And if we add the exponents, negative 1 plus a 3 is a 2. But what's the problem here? So this is a good answer. It's just not in what? It's not in scientific notation. It's a good answer, though. It's a perfectly good answer. It's just not in scientific notation. Remember the difference. If I asked you on a test to give me the answer, well, this is the answer. You can do this. And then you can move it twice. 1, 2. And you'll get 4,615. But if I said I want the answer in scientific notation, we have to put the decimal there. And now it's not going to be 10 to the second anymore. The decimal was there, but we moved it back 1. So now we have to go 3 times instead of 2 times to get the same number. And let's check. If we move this 3 times, we'll get the same number. It's important to remember, you want to get the same number. So that's in scientific notation. Okay, here's one. This one's a little bit of a challenge. Okay, so let's say I wrote out, write this out for you. Let's say I had 0.0003 times 10. We want to multiply it. Bring it over. And we want to multiply it to 3.45 times 10 to the negative 1. So right off the bat we have a problem because the top one's not in scientific notation, but the bottom one is. So let's fix it. So by the way, when you don't see an exponent, that means there's a 1 there. If you want to put the 1 there, you can. There is a 1 there when you don't see an exponent. Doesn't mean there's a 0, it's a 1. So what it's meaning here is that we should go over to there. It's telling us we should move it 1 space. That's what it's telling us. We should get this number, 0.003. That should be the number we want to get. So to fix the top number, remember in scientific notation we have a 3. Now how can we get 0.003 with the decimal being there? We have to go 1, 2, 3. Then we get 0.003. We have to move it 1, 2, 3 times. So it'll be 10 to the negative 3. That would be bring that over. So we can rewrite this whole thing. It'll be 3 times 10 to the negative 3rd power times 3.45 times 10 to the negative 1. So see what you get when you do that. Okay, so 3 times 3.45 is 10.35. Now remember we keep the same base, 10, and we add the exponent, negative 3 and a negative 1 plus negative 1 is negative 4. Now, what else is the problem? We have a good answer, but it's not in scientific notation. We want the decimal there. Now, the top number is telling us to go back 4. 1, 2, 3, 4. So we should have 2 zeros at the end from here. But now since we moved to here, we want to get the same number. So we go 1, 2, 3. We only have to move it 3 spaces. So that would be the answer, 10 to the negative 3. So again, remember, you want to try to get the same number, and that will tell you what exponents to use. We'll practice that. Look at these two and see if you can change them to put them in scientific notation. You should pause the tape. Okay, so again, if we kept it this way, we would have to move this decimal 12 times this way. But we want to put the decimal there, so it should be 3.5679. Originally we had to move it 12, but since we moved it 1, 2, 3 back, we have to add 3 to it. So that'll be to the 15th power. And this one, okay, we have 1.8 times 10. So here's the decimal, and we want to go back. This is telling us to move it 1, 2, 3, 4, 5. So if we want to move it to get the same number, what would we have to do? We have to actually move it back 1, and we'll get the same number. It'd be -1.